Today I'll talk about velocity field analysis, then I'll talk about continuity equation verification, and then acceleration calculation. Now here is the problem statement. In a fluid, the velocity field is given. So velocity field is given here. So that is V is equal to, okay, so here V is equal to 3x plus 2y I and 2z plus 3x square j and 2t minus 3z actually k. So here I, j, k are the unit vector. So now first determine first question is the velocity component u v w at any point in the flow field, then speed at point 111 at time t is equal to 1 second, then third question the speed at time t is equal to 2 second at point 002, and then classify the velocity field as steady or unsteady, uniform or non-uniform, or 1, 2 and 3 dimensional. So we have to classify that. Now question number 1. So now here that velocity field is, we know that V is equal to 3x plus 2y I plus 2z plus 3x square j plus 2t minus 3z k. Now we can write V bar, so that is nothing but ui plus vectorial form Vj plus Wk. So I, j, k are unit vector. So if I compare with this and this will be same V. So I will compare with I component. So u will be 3x plus 2y, v will be 2z plus 3x square, and w will be 2t minus 3z. So these are the component of the velocity. The next, the speed at point 111 at t is equal to 1. So now, so we know u is nothing but 3x plus 2y, v we know that is 2z plus 3x square, and w we know that 2t minus 3z. Now we plug that x is equal to 1, y is equal to 1 and z is equal to 1. So now here substituting x is equal to 1, y is equal to 1 and z is equal to 1 at t is equal to 1. So now for this u, so 3 into 1 plus 2 into 1, so that is 5. V 2 into z is equal to 1, 2 is 2 into 1 plus 3 x square, 3 into 1 whole square, so that is also 5. And w 2t, t is equal to 1, 2 into 1 minus 3 into z is equal to 1, 3 into 1, so that will be minus 1. Now so now that magnitude of the speed will be root over of u square plus v square plus w square. So 5 square plus 5 square plus 1 minus 1 whole square, so that is 25 plus 25 plus 1, so 51. So that is 7.14 units. So this is the speed of the velocity, means magnitude of the velocity at point x is equal to 1, y is equal to 1, z is equal to 1 at t is equal to 1. Next, that speed at time t is equal to 2s at point 002. So again we know that u is equal to 3x plus 2y and v is equal to 2z plus 3x square and w is equal to 2t minus 3z. So now plug t is equal to 2, x is equal to 0, y is equal to 0, z is equal to 0. So now x is equal to 0, y is equal to 0, so u will be 0. V is equal to 2z plus 3x square. Okay, so here 2 into 2 plus 3 into 0 is whole square, so 4, and w will be 2t, 2 into 2 minus 3 into 3z minus 3 into 2, so that will be minus 2. Now speed, that magnitude of the velocity, root over of u square plus v square plus w square, so 0 square plus 4 square minus 2 whole square, so that will be root of 20, so 4.47 unit. So now that classification. So now if you see here, so that this velocity depend on the t. If we give different time t, so velocity will change. So unsteady state means that velocity will not be constant, means that that steady is d by dt of u is equal to 0, means u will be constant. But here that velocity is not constant, it is change with time, so that's why it is unsteady. Velocity field is unsteady. Now here in earlier calculation, that different x, so uv different x, that u actually changing, even v will also change. So as that velocities change with the position, so that's why it is called that velocity field is non-uniform. Now here if you see, so this is nothing but, so velocities depend on x, y and z, so we can say that it is a three-dimensional flow field. Okay, now this is the first problem. The second problem, so we have to calculate, first we have to verify the continuity equation, then we have to calculate acceleration. So here in an incompressible flow, the velocity vector is given, so this velocity vector is given, so 6xt plus yz square I plus 3t plus xy square j plus xy minus 2xyz minus 6tz is equal to k. 6tz k. Now first verify whether the continuity equation is satisfied. To calculate the acceleration vector at point L 2 to 2 at t is equal to 2. Now so this is the problem statement. Now first that 3D continuity equation, we know that 3D continuous equation dou rho by dou t plus nabla dot rho into v is equal to 0. Now if we expand this, so that will be dou rho by dou t plus dou of rho u dou x plus dou rho v dou y plus dou rho w by rho dou z is equal to 0. So now here, as it is an incompressible flow, so rho is constant, so we can write that nabla dot v is equal to 0. So now if we expand again, so that will dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. Now as it is the velocity field, so you can write the velocity field in terms of ui plus vj plus wk. So now from here u is nothing but 6xt plus yz square, v will be 3t plus xy square and w xy minus 2xyz and 6tz. Now continuity equation we know, dou u by dou x plus dou v by dou y plus dou w by dou z. So first we have to calculate dou u by dou x from here, so that will be nothing but 6t and dou v by dou y, so from here, so that is nothing but 2xy and dou w by from here dou w by dou z, so that will give 2xy minus 60. Now if we add all together 60 plus 2xy minus 2xy minus 60, so that will be 0. So that it, now we can tell that it satisfy, means this is the set, this is dou u dou x plus dou v dou y plus dou w z is equal to 0, means it satisfy continuity equation, satisfy continuity